Hi, how are you doing? Welcome to the third video in the Pythagoras series. Okay, so what we're doing today is we're doing proving with Pythag. Pythag, right. So proving with Pythag. Now, the thing that you'll be asked to do, potentially, is to show that something's a right-angled triangle, okay? Or maybe show that it is not a right-angled triangle. Okay, so let's take a look at this. If they ask you to prove that something's a right-angled triangle, then the sides have to satisfy Pythag. We know that from Pythagoras. We've got this story. R squared equals x squared plus y squared if it's a right-angled triangle, right? If it's 90-degree triangle, right? But it also works the other way around. If it's a 90-degree triangle, then r squared equals x squared plus y squared, okay? So it works both ways. Pythagoras works if you're in a right-angled triangle, but if Pythagoras works, then you must be in a right-angled triangle. Does that make sense? Okay, so let's take a look at an example of how to use them. They say show that this is right-angled, and I'm going to use a Pythagorean triplet, so we know it's right-angled. So I've got the story there. Triangle ABC is right-angled, and I've got 5, 3, 4. Okay, so if it's right-angled, I've called this ABC, right? If it's right-angled, then Pythagoras must hold. So if it's right-angled, I've got c squared, so this is CAB, right? C squared must equal a squared plus b squared, all right? They haven't told me it's right-angled. Look, I don't have that symbol for right-angle drawn in there. So let's just plug it in and let's see what happens, okay? So c squared is 5, that's squared, right? Equals a squared is 4, plus b squared is 3, right? Well, 5 squared is 25, 4 squared is 16, plus 3 squared is 9, 25 equals 16 plus 9 is 25. Oh, 25. All right. So what do I get here? I get a tautology, meaning that I get the same equals the same. This is a true statement. Okay, I'll see when I get a fallacy in a second. This is a true statement. So because Pythag holds, therefore triangle ABC must be a right-angled triangle. Are you with me? Because Pythag holds, that means that this must be a right-angled triangle. Okay, it's a very small step, but it's just using the theory to show something else. Are you with me? Okay, so the next one underneath there, I'm just going to squash it in here just to make sure that it all fits. So I've got EG2, and I've got this story, 1286, right? 12 centimeters, 8 centimeters, 6 centimeters. 12 meters, 8 meters, 6 meters. 12 kilometers, 8 kilometers, 6 kilometers. Whatever the distance is. I'm not stressed about that. Okay, so they say, is this a right-angled triangle? Well, gee, golly bosh, sir. This here in the corner does look like a 90-degree triangle. I don't know why I slipped into American accent there. Anyway, this does look like a 90-degree triangle, so let's try and show that it's a 90-degree triangle. I hope I haven't offended any American viewers. Okay, my accent's horrific. Anywho, okay, so let's write down Pythag. I've got here r squared equals x squared plus y squared, alright? And let's put in the right things. So r squared is, I'm on blue with this one, 12 squared equals x squared, 8 squared, plus y squared, 6 squared. Are you with me? Tidy stuff up. 12 squared is 144, 8 squared is 64, 6 squared is 36, 144 equals 64 plus 36 is 100. Okay, so what is this? This is a fallacy. 144 is not equal to 100. Okay, I sincerely hope that you believe me with that. Okay, otherwise, if you'd like, I'll send you $100, you send me $144. Okay, we'll do an exchange. Okay, alrighty, but this is a fallacy. Okay, so that means because Pythag results in something that's not true, this cannot be a right-angled triangle. Okay, so therefore we can answer this. Therefore, what did I call this triangle? Triangle XYZ. Triangle XYZ is not a 90-degree triangle or right-angled triangle. Are you with me? Okay, because Pythag does not hold. This is an excellent example as well of why Pythag only works in a right-angled triangle. Because if I have to still put the things in, the hypotenuse, well, I have to call the hypotenuse because it's not right angle, but the long side and the two short sides I put them in, I don't get something that's true. Only in a right angle triangle will I get something that's true. You with me? Okay, so that's about as straightforward as it can get when you're talking about numbers, okay? So, is it right angle? Pythag works. Is it not right angle? Pythag doesn't work. Let's take a look at a slightly more advanced question where they could say, okay, great, super. Work out which side is the right angle, but they don't give you the picture. They give you just the story, so e.g. Now, in the notes, I've given the story and then I've drawn the picture, but I've taken this from an exam question where they said DE equals 13 centimeters, EF equals 12 centimeters, and DF equals 5 centimeters. Now, here's what I suggest you do. This is the question. They say, prove that this is a right angle triangle and then show which angle is the 90-degree angle. Okay, cool. And they've just given me this info. They haven't drawn a picture. So I go, right, no worries. Grab my pencil and let's assume it's right angled. So let's draw a picture. There it is. Okay, and now let's put in the distances. DE is 13, 12, 5. So this is the longest one. Now in any right angle triangle, the longest side is always your hypotenuse. So if we're assuming that it's a right angle triangle, let's make this 13 centimeters, which means that this has to be DE. So let's do DE. Okay, alright. If you label it the other way around, it doesn't make a difference. Just your picture won't be into scale. It's okay. Alright. So that has to be DE. Well then let's look for the second longest side. Well that's the second longest side. EF is 12 centimeters. So the second longest side of my picture is 12 centimeters. Let's make this one EF. Well, it has to be because that's E, so the other side must be F. And that leaves the only other option is DF, and that has to be 5 centimeters. Okay, fantastic. Now, sketch it. Take 2 seconds and sketch it so that you know what you're dealing with. You know which side has to be a hypotenuse. Well, if this is my sketch, then I'm expecting this to be my 90-degree angle, and then this has to be my hypotenuse. With me, because the hypotenuse is always the longest side. So, let's check it out. Let's first prove that it's right angled. So, for it to be right angled, Pythag says r squared equals x squared plus y squared. So, r squared in this case is 13 squared equals x squared, let's call it 12 squared, plus y squared, let's call this 5 squared. Right? 13 squared is 169, 144 plus 25, 169 equals 169. Fantastic. Right. So what does that tell us? That tells us, therefore, triangle DEF is a 90-degree triangle, all right, because Pythag works, okay? But now, which side is the 90-degree angle, okay? And angle DFE, remember the angle is always in the middle, DFE, okay? Is the 90-degree one, equals 90 degrees. Okay, because it's opposite the hypotenuse. Right, it's always the angle opposite the hypotenuse. If you have to sketch this out, it's pretty obvious that that is the 90-degree angle. But just looking at it like this, without all the information, looking at the question, it's kind of difficult to see which one is the 90-degree angle, okay, until you sketch it. I always suggest that if you aren't given a picture in geometry, any geometry, draw yourself a picture, okay? That's always my suggestion with the kids. Draw yourself a picture, fill in the info on the picture, and then go from there, okay? Very important, because it's nice to relate the written to the graphic, okay? Very few people can work just in written. A lot of people need the picture as well to compute what's going on, okay? So come watch this again if you need to. Remember, I'm here for you.